Leveraging Neural Networks for Real Estate Investment, a comprehensive guide. In today's fast-paced financial industry, data-driven decision-making is no longer just an advantage, it's a necessity. For financial analysts focused on real estate investment, navigating an ocean of data to identify potential opportunities is a daunting task. This is where neural networks, powerful tools in artificial intelligence, AI, come into play. Neural networks operate by identifying patterns in massive datasets, estimating probabilities, and making informed guesses. By integrating datasets such as geospatial information, mortgage records, economic indicators, political factors, and more, neural networks can provide valuable insights to pinpoint high-potential real estate opportunities. This video will decode how neural networks are trained, how they utilize pattern recognition, and how financial analysts can apply these techniques to develop simulation models specifically designed to evaluate and optimize real estate investments. Neural networks mimic the structure and functioning of a human brain. At their foundation, these systems consist of layers of interconnected nodes, or neurons, that process and transmit data. The three main layers in a neural network are the input layer, hidden layer, and output layer. Training a neural network involves feeding it a dataset and enabling it to learn through techniques such as gradient descent and backpropagation. Gradient descent adjusts the network's weights in small increments to minimize errors, while backpropagation refines predictions by working backward from the output layer to detect and correct inaccuracies. What makes neural networks exceptionally powerful is their ability to analyze complex patterns within data. Over repeated cycles of training and refinement, networks derive insights and probabilities from raw data, enabling financial analysts to interpret subtle correlations that would otherwise be missed. When applying neural networks to real estate investments, the quality and diversity of datasets matter. Accurate predictions rely on integrating and analyzing multiple data sources. Some of the most critical datasets include geospatial data, includes maps, locations, land usage, property density, and proximity to urban centers or amenities. This helps identify prime real estate locations. Mortgage records, data on mortgage defaults, credit risks, and borrower histories to assess financial risks associated with specific properties or regions. Economic data, indicators such as employment rates, average income levels, and regional economic stability drive long-term property value predictions. Building data, details about the size, condition, age, and design of properties. Macroeconomic trends, factors like inflation rates, interest rates, and GDP growth that influence market conditions. Political and regulatory environment, information on zoning regulations, tax laws, and regional political risks. Other relevant factors, data on crime rates, upcoming infrastructure developments, and environmental conditions. These datasets, when combined, provide a comprehensive picture of a property's value, potential risks, and overall investment viability. Building and training a neural network tailored to real estate investments is a multi-step process. Each phase adds an important layer of refinement to produce actionable predictions. All data sources must first be cleaned and pre-processed. This step ensures consistency by correcting errors, filling in missing values, and normalizing different datasets into a uniform structure. For example, geospatial data might require mapping coordinates, while mortgage records might need to be converted into probability scores for default risks. Neural networks thrive on complexity. Merging geospatial datasets with macroeconomic trends and mortgage records creates a richer dataset that yields deeper insights. This integration ensures that predictions account for multiple perspectives, improving accuracy. Different neural network architectures excel at analyzing specific types of data. Convolutional neural networks, CNNs, are designed for spatial data like maps and images, making them ideal for geospatial analyses. Recurrent neural networks, RNNs, are suited for time series data, which makes them effective for modeling trends in macroeconomic indicators or mortgage defaults. Once datasets are integrated and the architecture selected, the training process begins. Neural networks are trained through multiple iterations, optimizing their predictions using feedback loops that refine weights and biases. Finally, the model is tested on datasets not included during training. This ensures that the neural network can generalize its predictions beyond the training data, meeting real-world requirements. Simulation models are a powerful extension of the neural network framework. They enable financial analysts to evaluate multiple scenarios, predict outcomes, and identify optimal strategies. Input variables. Simulations begin with specifying a range of input variables such as political stability, economic growth rates, and interest rate trends. Training neural networks. These inputs are fed into pre-trained neural networks to examine their combined impact on real estate value projections. Testing predictions. The simulation generates what-if scenarios based on changes in key metrics, such as increasing inflation rates or shifts in zoning laws. Risk mitigation. Adjusting for potential risks like mortgage defaults or economic slowdowns. Forecast accuracy. Predicting market trends based on macroeconomic changes. Scenario planning. Exploring various investment options under different political or economic environments. For example, a financial analyst could develop a simulation to estimate how an upcoming tax regulation might influence housing demand across multiple regions. By interpreting patterns across diverse datasets, neural networks can deliver predictions for a wide range of scenarios. Here are some practical applications. Identifying prime locations. Analyzing geospatial data helps pinpoint high-value real estate locations. For instance, proximity to schools, hospitals, and infrastructure projects often correlates with higher demand and property values. Assessing risk levels. Mortgage data can indicate regions prone to higher defaults, allowing analysts to steer away from high-risk investments. Forecasting market trends. Economic indicators and macroeconomic trends feed neural networks to craft data-backed forecasts of future market shifts. Optimizing investment portfolios. Neural networks allow for balancing portfolios by assessing potential returns across diverse property categories and geographic areas. Imagine an analyst tasked with evaluating a suburban housing market near a developing tech hub. Multiple data sources, including zoning regulations, building conditions, and local economic growth rates, are fed into a neural network. The neural network identifies patterns suggesting that high housing demand over the next 5 years will be concentrated in areas within walking distance of planned metro expansions. Simultaneously, mortgage data reveals minimal risk in this area due to low historical default rates. By running simulations with various macroeconomic conditions, the model confirms investment viability, helping the analyst craft a compelling investment recommendation. Despite their advantages, neural networks bring unique challenges. Data accessibility. Obtaining comprehensive and reliable datasets is critical but often difficult. Overfitting risks. If neural networks are overly tailored to training data, they can fail under new scenarios. Interpretability. Translating complex predictions into actionable insights for decision-making requires careful simplification. Ongoing update requirements. Real estate trends evolve, necessitating regular model retraining with updated datasets. In a data-driven world, neural networks are powerful allies for financial analysts targeting real estate investments. By integrating diverse datasets, training predictive models, and utilizing simulation frameworks, they can uncover insights that guide strategic decisions and mitigate risks. While challenges such as data quality and model maintenance exist, their potential to simplify and optimize complex analyses makes neural networks an essential tool in modern financial modeling. With the right techniques and understanding, analysts can unlock opportunities hiding in plain sight. If you enjoyed this video, like and subscribe.